Hi friends. So today's coding challenge is to implement the doubly linked list. So let me explain you. This is how doubly linked list, which means a node has a reference to the next node, and the node also has a reference to previous node. So it's become easy to iterate from back to front and front to back. The only challenge comes here is to keep both the things like the head and the tail always updated and in sync. So I hope you will enjoy. Just try the code. So let's start it. Let me show you this. So we have a doubly linked list class. So the very important thing here is when you create a node. So let's say we have a node here. Now we need two things primarily. First thing will be your data and some previous and next references, which are more important. So this is previous, and then you have the next node. So each node will have a data and the previous and next. So once you create node, you are supposed to provide both these things, the previous and then the data and then the next node. So data would be D and then the next node. So let's assign this. So we would say first previous will be assigned, I mean it's just the reference, and then next will be assigned N, and then your data would be assigned D. So we are all set with this. Now let's try implementing. So we'll instantiate it, and then the first thing we need to do is we need to carry two things. First would be your first node reference, so that you can track it from front, like from here, which will be your header, and then you need to have the reference of your last element, and then you can also keep a count of how many integers you actually have. So having said that, now let's implement the first. So there are two ways here. First is you can add from front, and also you can add from back, so that you can maintain the sequence. Since you have a lot of items here and you want to maintain this sequence, so you can start adding at the back. So this is how we would try first adding the first. So you would have add from or add first, simple, add first and add last. So what would you do here when you want to add first? So first thing is you will create a node based on data, so whatever the data would come. So let's say your new node, so we can say new node is equal to new node, and then you can make this new node as a string, right? And then the value. So at this point in time, the value of the previous for the first node is of course null, because there is nothing before first, like before this. Sure. Then will be your data, so whatever the data you get, and then the next item. So what would be a next item? So as of now, we don't know, and we can always, add it later. So we would just add it later. Or another thing is you can just check if your, current first node is equal to first node. So that would be easier, right? So if you have a node already, the first node, then you're referring it to this. So what you're doing, that this is a data and you're inserting something else. So the previous would be nothing, but for this new node, the new first would become this. So we will update it in a bit, but right now what we did is we created the node and linked it. So now we have to update the reference for the current first node and then assign these value and also take care of the last, right? So your node has been created. Now your current first node, let's take care of that. So your current first node, for example, this, the link for next and previous are good, but this node's previous should be this, right? So let's check that. So we need to figure out if our first node is null, for example. So what we would do is our first node will be our new node, and we don't have to do anything. And also, if our first node is null, which means our last node will also be null. So we will assign both of these, the whatever the node we have. But if that is not the case, then our current first node first node dot previous. Actually, what we need is first dot previous would be our new node. So try to understand that what we did here. If our first node, we apply the new node over here, and then if first node was null, which means there was no data, so you also need to assign the last node also some value, and then you also need to make sure that your whatever was your last first node is referring to the previous node, and then you have to increase the counter as well. So what would you do once everything happens fine? You can increase the count, which will ultimately give you the size. So this is what, let's test it and fix it, if we find any problem there. So see, everything looks good. Let's try run. You have previous data, next. First is null, and then you are having the new node over there. If first is not null, then you're having the actual first previous as this, and this. Yeah, I believe this looks good. And let's also implement the size method, which will return the integer, and this would return the size. So the current size would be 0 when you start this, and then it would get 1. And let's first test these two things. So we have a linked list, and then we would assert the size to be 1. So we would do a size, and then we would say 1. What do you think? My heart is racing. Okay, I knew. So we need to fix something. 36. This is null. So it did not, if it would have been an int, it would have the default value of 0. But now we have to assign. So we are all set. Let's add couple of more data and test it, and then we'll also print it. So we have 0, 1, and 2. Yeah, size needs to be updated as 3. And to print, so let's have a method called as print forwards. So print forwards would do, first of all, we would say south system.out.println print forwards, and then what we need to do is first we need to take the first node. So we would say this is equal to the head. So once we have the head, we will start printing until n, yeah, first node. No, actually until n is not null, we would do system.out.println and then n.data. So this would print it, and we want it on the single line. So we would do this. So we have correct. So we need to reassign our n. So after printing, we would assign n.next. So until the last element doesn't reaches, this would keep on printing it. So let's print this, print forwards. Cool. So I think we have added three things, but somehow we are getting only first thing here, which is 0. So either it's a problem in our printing or it's a problem in our adding when we add. So again, check whenever you're getting the first, and okay, this is the problem. So when you have this null, then only you are defining the first as this, which should not be the case. The case should be as soon as you get this, you are reassigning the first element, and then this will never be the guy. So let's try it this way. So if you have the first is null, so you are also assigning the last, else you're assigning this, and first dot previous would come handy in case your first is not null. So I believe now this should print it properly, but it's just a hope. Yeah, and it worked out. So I'm pausing this video, and then in part 2 we will do add last and then removal methods. So stay tuned, keep practicing. Thank you.